In the last video, we were finding the center of mass of this super thin rod, and it had a constant density in the last video. It was a uniform rod. But now we have a variable density to this rod. So using what we saw in the last video, why don't you pause the video and try to find the center of mass of this rod? All right. Assuming that you've given it a go, again, we're kind of just doing a similar calculation to the last video, but now we have this variable density. So let's set up finding our x-coordinate of the center of mass, and we know it's these definite integral of, and then this can be x times dm, and divided by definite integral from a to b of dm. And again, this bottom integral is just the entire mass of this rod. So again, just talking about this, we are dealing with a linear mass density function. So we can quick bring that up. We said that lambda, which is linear mass density, is mass over length. And then when we started to talk about infinitesimals here, we saw that lambda is equal to dm, so a differential, a tiny chunk of mass over a tiny change in x, all right? And then we can solve for dm, so we found that dm is equal to lambda times dx. So now replacing these things, let's start filling in our integrals here. So we are going to have the definite integral, and the entire length of our rod, we're going to be looking at 0 to 2, so 0 to 2 of x, and then lambda. Lambda is now, we have a function here. So this is our variable density function. So we have 2x plus 2 now for lambda, and then we are integrating with respect to x. And then we're going to divide by the definite integral from 0 to 2 of, again, lambda times dx, which is 2x plus 2 dx. All right, now let's evaluate this and see what we get. So let me just clean up this top here. This is going to become 2x squared plus 2x, and then dx still. So anti-differentiating and evaluating both the numerator and denominator, we're going to get the following. So we have 2/3 x cubed plus x squared, evaluated at 0 and 2, and then divided by, in our denominator here, we're going to have x squared plus 2x, evaluated at 0 and 2. So what do we get? Let's see, 2 cubed, that's going to be 8, so that's 16/3 here, and then we have plus 4, and everything evaluated in here at 0 is just 0. So that's what we have in our numerator. And then the denominator, let's see, we have 4 plus 4. 4 plus 4, and that's going to be 8. So we can get a common denominator of 3, so that's going to be 12. So this is 28/3 in our numerator here, and then our denominator is 8. So we get what? We get 28/24, and then simplifying, looks like we can divide by 4. So we have 7, 6. 7, 6. That's the x-coordinate of our center of mass. And let's just see what that looks like. So that's a little more than 1. So that's going to be somewhere right in here. Okay. So that's our center of mass. If you were to put your finger up on that point for this rod, you would be able to balance it. And really just wanted to show you, okay, we don't have a constant density in this example. This is not a uniform rod. We have a variable density. It's varying in the x direction. And what does that look like in our calculations now? And we are done.